So in this video, we're going to go over network components, understanding kind of what is a endpoint, servers, switches, routers, firewalls, clouds, wireless controllers, and try to kind of understand where they sit in our network. Obviously, the comments I make on this regarding on where I believe they would sit isn't always necessarily true. So don't be concerned if you saw other sort of topology showing switches in different places than when I've said it. This is just a standard by the book where you would put this equipment. Also, don't be disheartened if you don't know how these devices communicate. Obviously, at this point, the goal of the video is to introduce you to the concept of a client, switch, router, and show you the symbols of these devices. What's also worth knowing is the video I done for the same content for the CCN ICND1, that's now retired, is still relevant. I'll link it in the description. Watch both videos, make sure you're happy with the content. This will cover section 1 of the new CCNA, Networking Fundamentals, and it's section 1.1, understanding the device roles and functions. Hello and welcome back to the CCNA journey with me, Ryan. And in this section, we're going to go over the roles and functions. For those who don't know, you can contact me on Twitter, here on YouTube, Facebook, or connect via LinkedIn. If these videos are helpful, please do like and subscribe. So endpoints and clients are the first thing that we're going to have a discussion about. Now, the terminology of a client normally refers to as an individual using the network, and the terminology of an endpoint sometimes refers to a device like a PC, but it could also be something like a laptop, it could be a mobile phone. Ultimately, it can be anything that's using the network. And it could even be something using the network that we as a user don't normally see, something like a server. This is also sometimes referred to as an endpoint. So it's important to understand that that terminology will change depending on who you're speaking with. But for now, let's think about an endpoint as a client and a client as a PC, or a device that you as an individual user will actually be using. Now, servers are normally something that the endpoints or clients are speaking with. So a good example of that will be you right now. You're on your PC, you could be on your laptop. This is my laptop, it looks terrible. And you could be even on your mobile phone, actually, to be fair, and you could be watching YouTube, this video, which is hosted on a server that YouTube is hosting for us. So this video is being streamed from a server to a client in order to give you content. So servers are normally devices that hold content for us. And they could be anything. They could be mail servers, they could be website, they could be video, ultimately anything. And they don't have to be on the internet either. They can be local in your premise. Now, switches are devices that allow us to connect things locally within a building. Now, as we continue in our networking career and our sort of certification track become more complex, we will start to realize that that's not always the case, meaning switches are not always local. But for now, at the CCNA level, we need to know that switches are local. Switches are ultimately something that's normally in your building. Let's say your office suite, for example, you would have a bunch of switches, and each of these switches will have what's called high port density. So they would allow 24 or 48 devices, maybe even more, to connect. And ultimately, all of your PCs or laptop around the office will connect into these devices called switches. And it will enable local communication. So if there's a PC that wants to communicate with another PC that's in the same building, they will go via a switch. So a switch is normally something local that's being used inside your network. You would also hear the terminology that a switch is a LAN device. A LAN standing for local area network. That's something that we will cover in a different video, but ultimately a LAN tends to be local to you in your building, and WAN, which is wide area network, refers to something outside the building. The next device we need to talk about is something called a router or router. Now, I call it a router because I live in England, but most of the world call it a router, and unfortunately out of habit, I call it a router. Now, the way routers work, routers allow LANs to speak to the WAN. So let's go through that picture again. Let's say we have a PC. The PC connects to a switch. And the way it connects to the switch is normally using an Ethernet cable. And you might have seen Ethernet cables many times before. And the end of Ethernet cable has got something called a RJ45 jack. And that's kind of like a plastic clip that clips into the back of the PC and it clips into the back of the switch. So this is kind of an example from an office perspective. So you have your Ethernet cables, and your Ethernet cables all run around the office into each of the buildings, and they all connect back into these switches. Well, normally these switches connect to each other to enable more port density, so more people can connect to them. But ultimately, these switches are going to connect into a device called, again, a router or router. And this device is what's called sometimes referred to as the uplink, which is the connection out of the office to the WAN. So here we have the LAN, and here we have the WAN. Okay, and that's how they all kind of connect together. So we have endpoints and clients connecting to switches. Servers can also connect into switches, but they may connect into the switch in the same premise issue or connect into switches at the other side of the internet. Like, for example, in YouTube's data center, there'll be a bunch of switches that their servers connect into. And there are also things called access points. Now, access points are ultimately a device that plugs into a switch and gives you wireless connectivity. So if you're on your laptop or your PC, you can connect to the network without having to use an Ethernet cable. So that's what an access point is. Now, if you ever think about your home a second, so taking away the office, where the office connects into switches and switches connect into the routers, normally at your home, your internet service provider, or maybe you have your own router, and that router normally offers you Wi-Fi, and it has a bunch of ports that work as a switch. So this device is actually like an all-in-one. It has an access point capabilities, it has router capabilities, has switching capabilities, and your clients, which is your home PCs, your mobile devices, whatever you have, connect into these ports or connect via Wi-Fi. So it does important to understand the networking components, but those components will be used differently depending on the network. And it's also important to know about the actual images that are used to represent components. Now, we know that this is a PC, that's quite obvious, and we can also see that this is some sort of tower that kind of represents servers, but not always are they this clear. Different engineers and different applications use different sort of symbols or icons to represent the network. There are a few standards to things, like for example with switches, normally you see a switch identified as a square with 2 arrows, or maybe a square with 4 arrows. That could be how a switch is represented. And a router is either a circle with a cross on it, or as you can see here, a circle with a bunch of arrows on it. So different icons can be different kind of symbols, but as long as you understand kind of the roles in the network, then you can sort of work out what are the components doing. Now, something that they've added into the CCNA, which I find quite interesting, is the layer 3 switches. And you might be wondering at this stage, because we've not talked about layers or talked about kind of what's going on as far as sort of why there's 2 different switches here. And this will become clear as you continue through your CCNA journey, but normally we say switches operate at layer 2. Now, I'm not going to go into what layer 2 is in too much detail, but it's something referred to as the OSI or TCP model, and it's a model that basically puts everything into layers, or at least tries to put everything into layers. Well, switches can operate at 2 different layers. They can operate at layer 2 and layer 3. Now, to give you a very quick example of a layer 3 switch, again, from the beginning, let's think about our clients and our mobile phones, and they all connect into a switch. Some of them connect through actually physical, some of them connect through maybe like an access point that plugs into the switch, but they connect to a switch, and the switch normally uplinks to a router. Well, some switches have router capabilities built into them, and they're referred to as layer 3 switches, because a router runs at layer 3 by default. So they kind of not, I wouldn't say kind of got rid of routers, because that's definitely not the case at all. And you'll find out why as we continue through the course. But a lot of the capabilities that routers can do can be done in switches now. And that's why they're called layer 3 switches. So you may see a switch that connects directly to the WAN rather than having to use a router that connects to a WAN. So that's the difference between a layer 2 and a layer 3 switch. Now, there's a lot more to it than just that, and we will get into it as we continue through the CCNA. The difference between layer 3 and layer 2 will become more clear, and the difference between the switches will also become more clear. The last point that's worth noting is the icon. Notice that the icon for layer 3 switch is different to the icon to a layer 2 switch. And again, if someone is doing a diagram, you would expect that to be shown in the diagram. Because if a device has routing capabilities, it needs to be shown in the diagrams. There are also something called the cloud. Now, the cloud is obviously picks up a lot of terms now. Now the marketing department's got hold of it. It tends to be used for anything. But as far as we're concerned, as a network engineers, the cloud is a simple way of representing something that you do not care about, you as a network engineer. So for example, let's say you're a network engineer for school and you're in charge of a couple of PCs, and these PCs connect into a switch, and then your switch connects into a router, and your router connects to an internet service provider that gives you internet connectivity. So we've got our router, we've got a switch, and we've got our clients. Well, your responsibility as a sort of IT administrator for a school ends here. So you don't really care about anything above the ISP, and as such, you can represent the ISP as a cloud. You can say, I know that if I send my traffic to Google and it goes this way, I don't know how it gets there, but it gets there. It's somewhere in the cloud. And that's how clouds are represented. Now think of it from an ISP's perspective, because the terminologies are always perspective related. So maybe I work as an engineer for the ISP. And from an ISP's perspective, they have a bunch of routers in their network. And then off this router here, let's say it's Netflix. And off this router here, let's say, is the school. Well, from an ISP's perspective, they might go, oh, well, from our point of view, that's the cloud. So it's important to know that a cloud is basically a part of the network that you, depending on your perspective, don't have the details on, or are outside your control, or you don't care about it ultimately. Now, the reason it's important to understand that is because the terminology of the cloud has been sort of used to represent a lot of things. Things that you might have heard of is things like AWS or Azure. So these are hosting environments that you can use that are sometimes referred to as the cloud. So it's important to know that really, as far as we're concerned as network engineers, a cloud is a way to represent something that we don't have the information about, or outside the scope of a network diagram. Firewalls are ultimately a bit of equipment that allows us to secure our network. So I'm going to draw it one more time, because the more we draw this, the more we remember it. So we have our clients, which are the end host, which again is you as an individual. The clients connect to switches to be able to speak to each other. The switches normally connect to routers, and then the firewalls before the internet. Sometimes the firewalls have routing capabilities, and they're instead of the router, and they connect directly to the switch. It depends on what capabilities that firewall has. But what a firewall ultimately does is something that a router cannot. A router is in charge of passing traffic from one interface to another. The same is true with a switch. But what a firewall will actually do is it will look at that traffic going in and out, and it will establish maybe this client, client A, is able to get to the internet, but client B is not able to get to the internet. The firewalls have the capabilities to prevent that. Firewalls offer capabilities such as, let's say I'm at home and I want to connect to my office. Let's say this whole room here is the office, and I want to communicate with device B because device B is my work PC. Then maybe the firewall lets me to communicate with that PC remotely and securely, but then doesn't allow other people on the internet to communicate with my PC. So there are ways to secure the network. Now there are other ways beyond a firewall, but a firewall is a key bit of device to understand. Within the blueprint, underneath firewalls, Cisco has outlined two other networking components they want you to be aware of. And they are the IPS and the NGFW. And they stand for the Intrusion Prevention System and the Next Generation Firewall. Now, the difference between these two is very much that the IPS, which is what I explained first, is a way to stop more complex attacks against your network. Normally when you're hosting something. So what do I mean by hosting? Let's say we have a client. The client connects into a switch. The switch connects to the router, and the router goes to a firewall which connects to the ISP where the cloud is. So that's the standard setup. Let's say in our network that we've chosen to host, as in put a server, and on that server there's a website. Let's say it's your business website, and your business website connects into the switch like so. And people out on the internet, whoever they may be, want to be able to access your website. So as traffic comes in, it will come from the internet, through the firewall, through the router, to the switch. So the traffic flow will come like this until it reaches the destination. All good. Well, the firewall is able to look at the source and the destination and able to identify whether that traffic is allowed or denied. What a standard firewall cannot do is interrogate or review the traffic that individual person is sending. So for example, it's able to see that it was a request for the website, but it's not able to see that maybe the request was a malicious request. So a particular client out on the ISP, out on the internet, is trying to crash your server. So it doesn't look at the malicious code or the request at a software level. So because of that, we can introduce normally something called an IPS, which sits behind the firewall, and it's able to allow or are able to view all the traffic the firewall is allowed, and it checks in a more in-depth manner to determine whether that request from the client to the server was malicious or not. And if it was, it's able to drop that traffic and prevent that attack. Now that's kind of what an IPS does. There's a lot more complexity to that, and it can do a lot more than that, but at its heart, an IPS is an inline device that allows the actual equipment or the communication to be interrogated in a more in-depth manner. Now, a next generation firewall is a method where we can replace our existing firewall with a NGFW. Again, NGFW being next generation firewall. And NGFW most of the time has things like IPS included. So it can handle that functionality without the need of an additional box. Now obviously there's benefits and downfalls in doing that, but for now all we need to know about is the next generation firewall comes with things like IPS built in. It also comes with other features like DLP, which is the data leak prevention, which is where, let's say this particular client inside your network starts emailing out a bunch of credit card details, then this firewall here, this next generation firewall, can see that traffic and stop it. Let's also say that there's a client up here who is part of marketing and they're allowed to use Facebook, but this client here who's part of sales is not allowed to use Facebook. Next generation firewall can give us that granular control. So as we can see, a normal firewall gives us networking control. Who can go to where based on an IP address or a port number. So based on network attributes, whereas the next generation firewall does it based on application attributes. So can you go to a particular website and actually has the ability to check the actual data that's actually included in the requests and the responses between the clients and servers. And an IPS is a standalone device that does not replace a firewall, but does a intrusion prevention of networking traffic where the firewall can't do it. So normally, in kind of most instances that I've dealt with anyway, you normally wouldn't have a standalone IPS. You would normally have a next generation firewall. But one of the biggest downfalls of doing this is, of course, how much traffic is going through your network. So if there's a lot of traffic going through, the next generation firewall is normally very expensive or can't handle that load. So if you need the performance, you need the actual speed of being able to check all that traffic, normally having a dedicated device like a standalone IPS will be much better than a device performing multiple function like an NGFW. And the last networking component are called controllers. And Cisco has mentioned two controllers. They've mentioned the WLC, which is the wireless LAN controller. And to give you an example of what that actually is, let's say, for example, you have a switch, and off the back of that switch, you have a bunch of access points. So these are kind of wireless access points that are different floors of your building that admits wireless signal to allow hundreds of devices to be able to connect to them, mobile phones, laptops, and so forth. Well, managing all of these devices independently can be very tricky. And what a WLC allows you to do is ultimately host a server, and that server is able to control, hence the word controllers, all of the communication to and from the access points without having to log on to each one. And the way that normally works is the controller speaks to each of the access points and is able to tell it, this is the wireless password you use, this is the wireless username you should be using, and is also able to give you a single view into what access points is up, which access points are down. So it's a central way to manage and to control all of your wireless access points. That's what a WLC is. And there's also something called the Cisco DNA, which is a new thing from Cisco, or at least newer than the wireless LAN controllers. And that's part of the software-defined network section that we'll get into as the course continues. So that's all we've got time for in this lesson. So it was basic in the grand scheme of things, but it's important that we understand the clients, what request traffic service, or normally where the traffic's going to and from. Both of these can be considered kind of endpoints, but it will depend on the person you speak to and the book you're reading, I guess. We talked about how IPS and next generation firewalls and how they differ from standard firewalls. We talked about switches, both at layer 2 and layer 3. We haven't spoke about what are these layers, and we don't really understand what these layers are at this point, but it will come clear as we continue through the study. But as we know, switches basically by default are at layer 2. Layer 3 are where routers live, but switches now have the capability of doing some of the jobs routers can do. Hence why you can have routers that can perform layer 3, and we'll go into a lot more detail about that as we continue. And we've looked at the different views and icons, understanding that actually, depending on which application you're using to build your diagrams, you could have different sort of icons and different colors and different ways to represent that. But it's important at least you understand a few things, like if you see a circle with a cross through it like so, that's normally a router. And when you see a square with some arrows on top of it, depending on how many arrows and what direction and so forth, that's normally a switch. So you can get an idea of what networking components you're looking at when you look at a diagram. Now, I hope this video has been informative, and I'd like to thank you for viewing. And if it has been, please do like and subscribe.